Hello everyone, and welcome to Statistics for Social Sciences course. Lecture 1, Introduction to Statistics. In this lecture, we will explore the fundamental concepts of statistics and understand its importance in social science research, especially in management. Course learning outcomes. Number 1, apply statistical theories and concepts related to social science research. This means students should be able to use statistical knowledge in real research situations in social sciences, like HR, management, education, or sociology. So students don't just memorize statistics. They have to use it in real research problems. For example, using some statistical concepts like mean, correlation, or regression to study employee satisfaction and productivity, or training effectiveness in organizations. Number 2, analyze and interpret data using descriptive and inferential statistics. This means students must be able to describe data and make conclusions from data. So students learn how to read data and understand what it means. Number 3, evaluate data using appropriate statistical techniques. This means students should be able to choose the correct statistical method for right situation. In simple terms, not all data use the same test. Students must decide which test is suitable for analyzing data. For example, if you want comparing job satisfaction between male and female employees, you have to use special test in statistics called t-test. But if you want to comparing multiple departments, in this case you have to use another test in statistics called ANOVA. And the last one, number 4, report data using SPSS software for descriptive and inferential statistics. This means students should be able to enter data into SPSS and run statistical tests. So interpret output tables and finally write results in academic format. So students learn to use software to do real statistical analysis and present results professionally. By the end of this course, students should be able to understand statistics, analyze data, choose correct tests, and use SPSS to report results. Today, we begin with a fundamental question. Why do we study statistics, especially in social sciences and HR? Statistics is not just numbers. It is a tool for understanding, analyzing, and making decisions in real life. Statistics makes work simple and gives a clear picture. It helps us summarize large amounts of data into simple information. Instead of looking at hundreds of employee records, we can use averages, percentages, or charts so managers can quickly understand situations and make decisions without confusion. Statistical methods are essential for conducting research in many areas like medicine, business, economic, and social sciences. In HR, you may conduct research on employee satisfaction, training effectiveness, or turnover rates. Why it matters? Because without statistics, research would be guesswork, not scientific. Number 3, statistics provides us different types of organized data with the help of graphs, diagrams, and charts. Statistics allows us to present data visually, making it easier to understand. Visuals help managers see patterns and trends quickly. Number 4 and last one, statistics comes handy while we do critical analysis. Statistics helps us analyze data deeply, compare results, and make logical conclusions. So we get answers of some question like, is training improving performance? Is one department underperforming? Or are salaries fair across employees? So it supports evidence-based decision making, not personal opinions. So in summary, statistics helps us simplify data, support research, present information clearly, and make better decisions. In social sciences like HR, management, psychology, we don't just study numbers. We study people and behavior. Statistics helps us convert human behavior into measurable data so we can understand it scientifically. So statistics is a branch of mathematics used to collect, summarize, analyze, and interpret data. In simple words, statistics helps us make sense of what we observe in real life. For example, imagine you collect survey responses from employees about job satisfaction. You get so many answers, confusing. It is called raw data. After that, by statistical tools, you can calculate average satisfaction score, you can find trends, you can make comparisons. Now the data becomes meaningful and useful. Types of statistics. In statistics, we generally divide the field into two main types: descriptive statistics and inferential statistics. And today we will also understand how we move from one to the other. Descriptive statistics is used to summarize and describe data. It answers questions like, what is happening? What does the data show? For example, average salary of employees, number of employees in each department, percentage of satisfied employees. We are not making predictions, just describing the current situation. So the key idea is descriptive statistics is describe the data only. Second type, transition. This is the bridge between describing data and making decisions. After we summarize data, we start asking, can we generalize this result? Can we apply this to a larger group? For example, you survey 50 employees in your company. By descriptive statistics, for example, you get 70% of employees are satisfied. So in transitions, we get the answer of this question. Can we say this represents all employees in the company? This step leads us to inferential statistics. Inferential statistics is used to make predictions or a generalization about a large population based on a sample. It answers some questions like, what will happen in future? Can we make decisions based on this data? For example, predict employee turnover in the next year, or decide if a training program is effective for all employees. So the key idea is inferential statistics equals to make decisions or predictions. When we collect quantitative data means numerical data. We have two main ways to analyze it: descriptive statistics and inferential statistics. Let's understand the difference more clearly. Descriptive statistics are used to summarize and describe the data we already have by mathematical summarizes and it focused only on the given data set. So we are not making any generalization or any prediction, only describing what we see. But inferential statistics go one step further. They help us make conclusions about a larger population based on a small sample. They are used when we want to generalize results, make predictions, support decisions. Here, we move beyond the data we collected. So inferential statistics is draw conclusions and make decisions. We have several types of descriptive statistics like measures of frequency, measures of central tendency, measures of dispersion or variation, and measures of position. Measures of frequency like count, percent, frequency are statistical tools that show how often values or categories occur in a data set. They help summarize data by counting occurrences, usually using frequency table or percentages. Measures of central tendency are statistical methods used to identify the single value that best represents the center of a dataset. They include the mean, median, and mode, which summarize data into one typical or central value. Measures of dispersion or variation describe how spread out the data values are around the central value. They show the degree of variability in a data set using measures like range, variance, and standard deviation. Measures of position indicate that relative standing of a value within a data set. They include percentiles, quartiles, and z-scores, showing where a score lies compared to others. We will study these tools in detail step by step in the forthcoming lectures. Inferential statistics. In real life, it is often impossible to study every single individual in a population. So instead, we study a sample and then use statistics to make conclusions about the whole population. This process is called inferential statistics. So here we have to understand the concept population and sample. Population is all individuals, for example, all employees in a company. But sample is a small group selected from the population randomly. So why we study the sample? Because it saves time, it reduces cost, and it's more practical. Here we have an important note. For inferential statistics to be accurate, the sample must be random and the sample must be representative. Otherwise, the conclusion may be incorrect. In this slide, we have some statistical tools that are related to inferential statistics. For example, t-test. A t-test is a statistical test that can be used to compare means. There are three types of t-tests we have. The first one is one sample t-test. It is used for compare the mean of one sample or one group to the target value or standard value. The second one is independent samples t-test. Is used for comparing the mean between two independent groups. And the last one is depend sample or paired sample t-test, is used for comparing means between related groups. On the other hand, we have ANOVA test or analysis of variance. This is a statistical test that is also used to compare means for more than two groups. And we have a correlation technique. It's a statistical technique used for determine the strength and direction of relation between two or more variables. And we have regression tools that allows to make a prediction about an outcome based on knowledge of some predictor variables. So these tools are related to inferential statistics. We will study in forwarded lectures step by step in detail. In this slide, we talk about variables. In statistics and research, we don't just study things. We study variables. A variable is anything that can change or vary from one individual to another. So a variable is a characteristic or condition that can take different values. It is not fixed, it changes. For example, salary, different for each employee. Age varies between individuals. Satisfaction, high, medium, low. Gender, male, female. So the key idea is, if a condition, it can change, so it is a variable. For more explanation, in most research starts with a question about the relationship between two variables. For example, does one variable affect another, or is there a relationship between them? For example, in HR, training, it has an effect of performance, or is there any relationship between salary and job satisfaction, or is there any relationship between working hours and stress level? So why variables are important? Because it helps us structure research, allow us to measure and analyze relationships. So variables are the building blocks of research. By studying how variables change and related to each other, we can understand real-world problems in HR and social science. After understanding what a variable is, the next step is to classify variables into types. This helps us decide how to measure, analyze, and interpret data. Variables can be divided into two main types: discrete variables and continuous variables. Discrete variables, these variables consist of separate and distinct categories. They cannot be divided into smaller parts. Values are countable and fixed. For example, number of employees in a team. So discrete variable is countable and separate categories. But continuous variable, these variables can take any values within a range and can be divided into very small units. Values are measurable and flexible. For example, salary, time spent on training, employee age. So continuous variable is measurable and can take any values. And we have an example in this slide. Time is a continuous variable because it can be measured in minutes, seconds, even fractions of seconds. There is no limit to how precise we can measure it. So when we have a quantitative data or numeric data, if the data can't be measured, but it can be counted, this type is called discrete data. But if the data can't be counted, but they can be measured, this type of the data is called continuous. In other hand, data can be grouped into four types of measurements: nominal, ordinal, interval, and ratio. Nominal measurement is the most basic level of measurement, where data are classified into categories or labels without any numerical meaning or order. It focuses on quality rather than quantity, meaning the numbers assigned such as, for example, 1 for male, 2 for female, are only used as a label and do not represent value or magnitude. In this level, categories are simply used to distinguish or group data, such as gender, meal preference, breakfast, lunch, dinner, or time of day, AM and PM, and even binary coding like 0 and 1 in computers represents categories rather than quantities. In HR, nominal variables are useful for grouping employee, for example, department, job role, but they cannot be used for calculation like average because they do not carry numerical meaning. Ordinal measurements refers to data that can be ordered or ranked, meaning it provides both categorization like nominal data and a sense of direction, higher or lower, but without indicating the exact difference between values. For example, categories such as low, medium, high, or rankings like first, second, and third show clear order, but we don't know how much differences exist between them. Similarly, in scales like rating an experience from 1 to 10, we know that 9 is higher than 6, but the gap between them is not necessarily equal and measurable. In HR, ordinal data is very common, such as employee satisfaction level, no, maybe, yes, or performance rankings, where we can compare position but cannot perform precise mathematical calculation like average with fully accuracy. Interval measurement is a more advanced level where data not only have order like ordinal, but also equal and consistent intervals between values, meaning the difference between numbers is meaningful and measurable. For example, the gap between 1 and 2 is the same as between 7 and 8 on a rating scale. This allows us to perform calculations such as addition and subtraction, making analysis more accurate than with ordinal data. A common example is time on a 12-hour clock, where the difference between 1 p.m. and 2 p.m. is the same as between 11 a.m. and 12 p.m. However, interval scales do not have a true 0 point, so we cannot say one value is twice another. In HR and social sciences, interval data can appear in standardized tests or rating scales where distance between scores are equal, but 0 does not represent a complete absence of the variable. Ratio measurement is the highest level of measurement, as it includes all the properties of nominal, ordinal, and interval scales, but with the added feature of true or absolute 0 point, meaning a complete absence of the variable being measured. This allows for meaningful comparisons such as twice as much or half as much, which is not possible in other scales. For example, variables like number of children, years of work experience, or time in 24 hours or clock, where midnight represents 0, all use ratio scales because 0 has real meaning. In HR ratio, data is very useful for analysis. For instance, an employee with 10 years of experience truly has twice the experience of someone with 5 years, making this scale the most powerful for statistical calculation and decision making. Levels of measurements can be arranged in hierarchical order known as RION, which stands for ratio, interval, ordinal, and nominal, ranked from the highest to the lowest level of measurement. This hierarchy shows that each higher level includes the properties of the levels below it. For example, ratio data has all the features of interval, ordinal, and nominal data, while nominal has only basic classification. Understanding this order is important because it helps researchers choose the appropriate statistical methods. The higher the level, like ratio, the more powerful and flexible the analysis, where lower level, like nominal, are more limited. In HR and social sciences research, recognizing this hierarchy ensures that data is analyzed correctly and meaningful conclusions are drawn. Statistical notation refers to the symbols commonly used in statistics to represent data and make analysis simpler and more standardized. For example, capital X and capital Y are used to represent scores or variables such as salary or performance, while capital N refers to the total number of observations in a population, and small n refers to the number of observations in a sample. Another important symbol is the Greek letter called sigma, which represents summations, meaning the total of a set of values. For instance, summation of x means the sum of all values of variable x. These symbols are essential in statistics because they allow researchers and analysts, especially in HR and social sciences, to express calculation and formulas clearly and efficiently without writing long explanations. In this slide, we have a numerical example represents a given value of x 2, 3, 4, and 5, and given value of y 6, 5, 4, and 3. And x times y means 2 times 6 is 12, 3 times 5 is 15, 4 times 4 is 16, and 5 times 3 is 15. Based on the above table, we can calculate summation of x. Summation of x means that add all the values of x together. 2 plus 3 plus 4 plus 5 is equal to 14. And summation of y means add all the values of y together. 6 plus 5 plus 4 plus 3 is 18. Summation of x times y means add all the value of x and y together. 12 plus 15 plus 16 plus 15 is 58. And here we have summation of x all square. Previous we have summation of x equal 14, and here just we square it. 14 times 14 or 14 square equal to 196. And this is a simple example for how summation is used, and in the next lectures we will study the rule of summations by detail and step by step with examples. In the last slide we have some links and sources to get more information about this course. This concludes today's lecture. Thank you for watching, and I look forward to continuing with you in the next session. Goodbye.